Hello everybody and welcome to another very exciting tutorial. Bernardo here for the oven, and what I want to show you today is how to create this nice vortex particle simulation right here. It's a simulation with a twist, and it's one of the scene of the video that I released today with several particle simulations. We're gonna look at it soon before we start the tutorial. Uh, yeah, and I'm gonna show you this particular simulation, but what I think is, what I hope you'll get out of this tutorial are some concepts that then you can use to create your own material, your own ideas, your own scenes. So let's have a look really quickly at the video I was talking about, and then let's dive right into the tutorial. Okay, let's do it. First, let's add a plane, and this will be our emitter. Let's rotate it on the x-axis 19 degrees, scale it down on the z-axis, and make it a little bit wider, like so. Let's add a new particle system. So particle properties, add a new one, and we can start simulating. Okay, first thing we want to avoid is the particles falling down. So we want to turn off gravity in the force field. Gravity, let's set it to 0. Nice, and this is what we want. Now we also want to set the end of the emission time to 250 and the lifetime to 250. For this tutorial, we're going to record 10 seconds. We're going to bake 10 seconds of animation, and that's 250 frames. And let's also increase, for the moment, the particles number to 20,000. We'll go a bit higher later on. For the moment, that's fine. And finally, viewport display size, we want to make that a little bit smaller so we can see better what's going on. Okay, so this is a good start, but we've got to make this animation a little bit more exciting, and we're going to use force fields to do that. So first of all, let's add a new force field, turbulence force field. And what the turbulence force field does, sorry, is it creates like a network of distorted turbulent noise in the air, and the particles are going to follow that. For now, we can't see any difference, and that's because here in the physics tab, we've got to play a little bit with the settings. So strength, that's the overall intensity, and if we turn that up to 3, you can see the particles start going crazy. That's a little bit too much. Let's put down to 2 for the moment, but we'll come back to that later. Then we've got the size, and the size is the size of the noise that is created in the air. A little bit like a noise procedural texture size, same thing. So you have to imagine there's this noise in the air and the size, change that. I'm not sure what happens when it's size 0. Like it probably automatically sets some size on its own, but for this situation we're gonna go maybe 0.5, maybe we'll tweak it later, we'll see. And finally we've got the flow. Now the flow is basically how much this noise field affects the movement of the particles. So at the moment you can see that the particles start with a perpendicular velocity, and then they're being affected by the force field, the turbulence force field, but they keep going forward a little bit. Now if I increase the flow value, you can see that the particles immediately slow down, and then basically all that is affecting them at that point is this turbulent field. And this will allow us to have a more defined uh, like noise shape in our particles trajectory, which is nice, but we don't want them to slow down like this. But we're gonna fix that in another way. So for the moment, let's leave these settings as they are. Let's go back for a second to the particles settings here. And in velocity, I also want to turn down the normal velocity. So what the normal velocity is you can see at the beginning the particles are moving in this direction, and the normal is basically the perpendicular direction to the plane. Okay, so the plane, when emitting particles, is adding a 1 meter per second velocity in the perpendicular direction to each particle. And I want to turn this off. So now you can see that the particles, so that the simulation started, they just stay there, and now all that is affecting them is the turbulence, noise, force field. We don't want that. We want the particles to go forward like they were doing before, and to do this, we're going to use another force field. So let's add a wind force field. So we have this thing, let's move it back a little bit. The position won't matter, the position of the wind. You can see now the particles are going up. I want them to go as they were going before in the y-axis. So let's rotate this on the x-axis 90 degrees. And there you go. So now you can see that the particles are being pushed all the time because this force field is affecting them all the time towards this direction. And at the same time, we have that nice defined shape of the turbulent noise, okay, which is exactly what we wanted. Now, before we can call this simulation done, I want to do something else. If we go to side view, you can see that the particles are going a little bit too much up and down for my taste, okay? And I would like them to resemble like a thinner sheet of particles. Sorry if I mispronounced that word. It's a really tricky one to pronounce for a non-English native, but I guess you understood what I meant. So we want them to be thinner. And to do that, we're going to use another force field. But this time, instead of adding a force field, I just want to add a new plane. Okay, let's scale it up and move it a little bit forward. Don't move this edge too close to the meter because that can create some confusion to the particle simulation. Okay, now let's quickly go here into the object properties, viewport display, and set the display as wire. So this way it's going to be easier to see them. And finally, let's go here in the physics tab and add a force field. So as you can see, I can add a force field right to this mesh. And the reason I did that is because now I can go here into the shape menu and set the shape to surface. So basically now every point on the surface of this plane is emitting force. And in this case is emitting strength 1 force in both perpendicular directions to the plane. So it's working just the opposite as what we want. So let's set the strength to -1. And now you can see we're getting exactly what we wanted because this plane, if we go again to side view, is keeping our particles nice and close to itself, which again is exactly what we wanted. Now let's do the final tweaks. Maybe let's go again to the turbulence noise, turbulence force field, and maybe let's try to increase the force a little bit and even the flow. Let's see what we get. And you can see now the particles are following even more those noise fields in the air, which I think is nice. But you can play with the settings and just try to achieve the effect that you like the most. Okay, maybe the force is a little bit too much at the moment. And finally, I also want to maybe increase a little bit the strength of the wind to make them go a little bit faster so that they reach a little bit further. Okay, yeah. So I think I'm quite happy with this simulation. As I said, just play with the settings of the force fields, be creative, and get the result you want. Now we can go back to our emitter particle settings, and I will increase the particle count to 100,000. So just a little note here. Obviously, the higher you go, the nicest effect you can achieve. It also depends on what kind of effect you want to achieve. But to achieve an effect like the one in my videos, in some of the simulation, I think I went up to 2 million particles. Just be aware, bake times, export times, render times, viewport, it's all gonna get quite heavy and long. Uh, a good computer will help, but unfortunately Blender, for example, as far as the viewport go, I don't think there's any computer that can handle easily 2 million and plus particles, because we're gonna also increase the number later with other methods you'll see soon. So yeah, just keep that in mind. But for this tutorial, let's go 100,000 particles. It's a good number. You know, it will allow us to keep the times down, but we'll still see a nice effect. Now, before we bake, we want to do something else. If you go here in the output properties, I want to set the frame rate to 25. That's the frame rate I usually go. And this is really important because we want to bake the particles and then export the particles with the same frame rate. Otherwise, we might have some glitch and trouble. Actually, we not might, we will have. So let's set this to 25. Let's go back to the particles here. And where is it? Cache, bake. All right, here we go. So the simulation is baked, and you can see the effect. Again, I think for 100,000 is quite nice, but feel free to go higher if you want. Maybe do some tests first and then go higher. Okay, let's go on. Now, you can see this doesn't look at all as the video that I've showed you. And we're gonna get there now, but we're not gonna get there just with simulation. So what we want to do now is we want to export this as an Alembic, and from there, thanks to the Alembic, we'll be able to do a lot more. We'll see that soon, but first let's export it. So let's add a plane, and in edit mode, I'm going to press M while all the vertices are selected and select merge at center. Now what this does is it creates a single vertex right here. Let's call this maybe, I don't know, particles vertex, just to be a little bit organized. And now with the particle vertex selected, I go to modifier and I will add a particle instance. What this modifier allows me to do is to instance one copy of this mesh, which is my vertex, onto each particle of a particle system. Okay, so to do that, I'm just gonna click on the pick thing here of the modifier and then select the plane, which was my emitter, and you can see now that one vertex appeared into each particle, which is exactly what we want. I want to turn off dead and unborn, okay, because you can see here unborn, basically there's a lot of unborn particles yet at this point of the simulation, and I don't want them. So turn this off and turn off that. And yeah, we're good to go. So now with my particles vertex selected, I go to File, Export, Alembic. I go somewhere where I want to export this. And then I just double check here, frame start, frame end, 250, that's fine. And I want to select objects only. And this is going to allow me to export only the object that I selected, which is what I want. Give it a name and export. This is going to be quite quick. Again, remember the number of particles is going to affect this line quite heavily, so keep that in mind. And there we go. Now, I would recommend that for the rest of this tutorial, you go into a new blend file because basically you would keep this file which is created now as the simulation file, and for the render file you take another one. This is going to be good, especially if you go up with the number of particles in the simulation, because the simulation file can get a little bit clunky when there are a lot of particles. So yeah, just keep that in mind. For this tutorial, I'm just gonna keep it here, just not too many particles, but just a little advice for you. So let's rename this simulation, this collection, and let's turn it off. And now we go to File, we import Alembic file, we go where we saved our file, select it, and import it. And now you can see immediately, if I start to scrub through the timeline, you can see our particles, which are not particles now, they're just points. This is our modifier, so we have a new object, which is just a mesh, and there is this modifier, which is basically what's loading the cache that we've exported before as an Alembic. Okay, and this is really nice. Okay, let's see how we can make this look differently. Okay, now I've mentioned that we can do a lot of stuff thanks to the fact that we've exported the simulation as an Alembic. And what I meant by that, you can see here now, this is a mesh. I have the ability to add any kind of modifier I want. So I can do all sorts of crazy stuff with this thing. You know, I can deform it, I can add curves and so on. So let's see what we can do. We're going to create that vortex effect. So let's start by adding a path. Okay, here it is. And adding a path, and then let's move it a little bit down here. And I want to create this kind of trajectory like this. Oops, going down. Okay, done. Now select this, our Alembic simulation, and add the curve modifier. Let's select the curve, and you can see now this is being deformed along the curve. I just want to rotate it 90 degrees. Okay, there you go. So now we've got our particles, which are, as they go forward, they actually follow our curve. Okay, and just to show you, that's not what we're gonna do in this tutorial, but just to show you, if I were to take the curve, go in edit mode, and then press Ctrl T, which is what I can use to change the tilt of the curve, you can see I can deform the curve, and the particles are gonna follow that. So again, the exporting the simulation as an Alembic gives us a ton of new possibilities to play with. Okay, just get creative. I'm going to show you this, but just get creative with your ideas, experiment, and so on. Now, let's go forward. Let's create another curve. I want a circle this time. Okay, and make it a little bit bigger. Put it here. Now I'll add a new curve. Select our circle, and you can see that this is a little bit wrong. So now we have to change the forming axis to Y. Nice. So we start to see this is a little bit better, just the direction is wrong. So what I want to do, I go in edit mode while my Bezier circle is selected, Control T for the tilt, changing the tilt, and I want to change the tilt by 90 degrees. Okay, so now I get these, and I want to scale up our circle so that now I get this shape basically. Now you can see we're missing quite a chunk of our circle. Now to fix that, let's add an array modifier, and I want to bring it all the way up. Up as the before all the curves modifier. Okay. And what this does, you can see, let's turn off the curve modifier. So I have this, and now I'm arraying this along the x-axis, then I'm deforming it like this, and then I am following this curve, and then I'm deforming it following our circle. So now we have our circle here completed, and you can see that the particles go in. Okay, that's all really nice. We've got just a little problem. You can see here as I scrub through that the distance between our arrays is changing. Okay, and we can fix that. That happens because at the moment the array is set to relative offset, and the relative offset basically takes 1 unit based on the length of the object. Problem is here that the length of the object is changing, because you can see at this point here, if I turn this off, this point here, the length of the object is up until here, but if I go up, the particles go past this point, so the relative distance changes. And to fix that, we just turn the relative offset on, and we'll use a constant offset. So this offset is independent from the length of the object. So let's just set it like this, and you can see that now the problem is fixed. So we turn back on our curve modifiers, and there we go, nice and stable. Now let's add the last piece of deformation. Okay, I want to create a vortex effect. Now I could use a simple deform modifier. Okay, twist and set it to Z, and you can see it works quite well. However, for some reason I found that, as you can see at the beginning, it goes a little bit nuts. I'm not sure why that happens. If you have any idea, let me know. Maybe you know, you can help me and all the viewers of this video to understand. Yeah, I tried to make it work. I couldn't, but we have an alternative solution. So what we can do, okay, is I can add a lattice object, scale it up in object mode. Okay, scale it up and scale it up like this. Not too much. Right until here. Okay, we scale it like this. We add a little bit of division on the W, which is I would say like the Z-axis. Okay, so it's nice. And now I can actually, I think, add just a simple deform modifier over here. Still twist Z. Okay, so this is gonna do something similar, and now I can add a lattice modifier to our simulation and select the lattice, and there we go. Now we've got our vortex effect. It deformed a little bit here at the sides, but that's not a big deal. If you want, you can try to fix it with the curve, but yeah, it's not that big of a deal. And yeah, we got our vortex effect. I can increase it maybe a little bit further. And the nice thing also, what I can do now is that I went to edit mode. For some reason, Blender doesn't allow you to modify the lattice shape if you have modifiers active. So I turn this off for a second. So the nice thing of having a lattice modifier is that I can change the shape of this thing in many ways I want. Okay, so you can play around with that as well. As I said, you have, now that this is an object, this is a mesh, you have an entire set of modifiers and every trick you know about meshes to deform this thing. So yeah, I think this is really cool. For example, I can add here another simple deform, and maybe use I don't know, stretch on the Z-axis. Yeah, you can go crazy with it. Taper. You can do all sorts of things. Just play around with that. Okay, now what else have we got? So I think we are pretty good as far as the shape goes. Okay, we've got this pretty cool movement here. The problem is that because those are vertices, or just points, cycles, or EV for that matter, won't render them. So to render them, we're gonna instance some balls, some molecules, some anything, and we're gonna use geometry node. So let's go here. I split the viewport, change to geometry node, and with our simulation selected, we press new. Okay. Now, before we proceed, let's add our molecule. Okay, so let's add a new mesh plane, and the reason for the plane I'll explain soon. Let's change the size maybe to, I don't know, 0.1 meters, and apply the scale, because otherwise things will not go as we expect. And then we can add a solidify modifier, set the thickness to 0.1, so we've got a perfect cube, and offset to 0, so now the origin is in the middle of the object. And finally add a subdivision surface modifier, shade smooth, and there we go. So this is a nice little sphere, and the reason I didn't add the sphere from the beginning is because this way I can turn off these modifiers and make my viewport much lighter, okay? Because we're gonna instance this mesh onto each one of these points. The viewport can get quite slow, and with this, you know, you can add a little bit of performance to your viewport. We're probably gonna be fine now because we have about 300,000 points maximum. But you know, if you go up some millions, then things can get pretty heavy. But enough of that. Let's get down to the instancing. So in the in the geometry node editor, let's go to add point and point instance. And what this little node does is exactly what it says. It will instance an object. In this case, you can also instance an entire collection, but we want just an object on each point. So you can see everything disappeared because we have to choose what we want to instance, and we select our plane. Let's also maybe rename this to molecule. Yeah, it's a bit nicer. Okay, now you can see actually that I thought we were gonna be a little bit better, but actually the viewport slowed down quite a little bit. Okay. So if I were to have, if I was to have a sphere here, things would be even slower. So that's why I've used this method again. But yeah, in this case, the sphere is quite okay. Now, for my tastes, the only thing I want to do, like the size of the sphere is too big. You can change it here, but I think directly from the original mesh, but I think it's much easier to just add an attribute fill node, put it before the point instance, and write in the attribute scale. Everything disappear because the value is 0, and now I can set it, I don't know, 0.3. Yeah, something like this. The size here will change depending on how many particles you baked. The more particles you baked, and the more you'll be able to go down with the scale and still have a nice effect. So you're gonna have to see how many particles you have. But this is it. Now you can give a shader to your material and add the lighting. But now this thing will render, and yeah, you have your animation of the vortex particles going down. So again, this is it. I hope you've enjoyed this tutorial. Let me know if you have questions, if you have suggestions, and what you would like to see next, maybe going deeper about this argument into some of the topics, or maybe something new. I'm preparing more tutorials, but I'm really interested in knowing what you guys and girls would like to see on this channel. So yeah, have a good day and see you soon.